The Python programming language is an excellent programming language to get started with. It's one I started with in the journey of learning how to program, and it's changed my life completely. But there's sort of two things that trip up beginners with Python programming. One is installation with different types of versions. Is it Python 2, Python 3, Python 3.11, Python 3.10, and virtual environments. That's kind of what I want to run through today, is how I manage with different versions of Python and how I deal with what we call virtual environments for your projects. So let's jump straight into it. Now, the first thing I want to touch on first is Python version. So when you start off with Python, you're very likely going to be using one version of Python. So for me, I think that was 3.8. But what happens is every year there's a new release of a Python version that comes out. So for example, the year after that was Python 3.9, 3.10, and those come with new features. The issue with that is when you try to install Python, you install multiple versions of Python. Imagine you've got multiple projects, when they use different versions of Python, it can be a big mess. So I kind of want to run through how to set up a project for a particular version of Python and having multiple versions of Python running on your system. So a tool I like to use to help me manage different Python versions is called Pyenv. So a lot of people will think this is overcomplicated, but I really like using Pyenv to manage different versions of Python. Here is the project here. And there's different ways of installing it. I'm currently running Macintosh or Mac OS, so I use Brew to install Pyenv. There's multiple ways of doing it. You can use, for example, if you're running Windows, there'll be ways of installing it via Windows or using an automatic installer. But I use Brew to install it, and I involve setting it up via Fish. So it is a bit of a workaround for that, but totally useful in the end. And essentially, I think what Pyenv does, it will sort of isolate your version of Python, and you can always change between different versions of Python. You can set up for a particular project, you can include a file called, I think it's Python versions, and that particular file will when you create like your virtual environment there, it will call that particular version of Python. So let's run through Pyenv and see how it works. If I just type in the command Pyenv, you'll see it comes up with a list of commands. And if I type in Pyenv versions, it shows the versions that are currently installed on my system. So I've got 3.6, and how it works is this is the major version. So obviously got the system Python, which I can't remember what it is on Macintosh, Mac OS, and I believe Mac OS comes pre-installed with Python 2.7, but I could be wrong, so you could correct me on that. But you can see here we've got different versions of Python. So I've got 3.6, 0.15, all the way up to 3.11.1.3, and there's 3.10.0.7. So I think Python 3.11 has been upgraded beyond 0.1. So how the versioning works is semantic versioning. 3 is the major version. This is the minor version, which is usually every year, and you got patches or fixes of particular security vulnerabilities or problems that pertain to the Python version. You'll get this number updated, and the idea is 3 is supposed to be really big changes. This here is usually new features, and Python doesn't maintain back compatibility, so you're never ever going to get a feature in 3.5 that won't work in 3.11, but you'll get features in 3.11 which may not work in 3.6, if that makes sense. So and you've got the patches here which aren't supposed to be breaking changes. So for example, Python code that runs on 3.11 with new features should be able to run on every single version of Python 3.11. And the idea here is this is just for fixes and bugs and small things like that. So let's look at the versions of Python we can install. So I think if we go Python, I need to look at Pyenv and look at how to get all the versions. This is the versions that I have installed on my local machine, and I believe there's a way to get all the versions of Python. So I think is it Pyenv install list. Here we go, and you can see here this is the entire list of all Python type things that can be installed. So for example, you can do Anaconda's installation or installation of Python. You got Miniconda here too. It's not just Python or Pyenv. So you got all the Minicondas here that you can install as well, and you got PyPy as well. But let's try and find the latest version of Python 3.11. So if I do this and grep 3.11, so you can see I've already done this. You see here the versions of Python here. So now we've got the most latest patch here, which is 3.11.3. So if I do Pyenv install 3.11.3, and this will install Python 3.11.3. Just takes a while. Cool, so we're done installing. So let's have a look at the Python versions again. So if I go Python versions, you'll see that down here are my versions. So I've got 3.11.0.1.3. So that's a newly installed version. And I think just to make things a bit cleaner, let's just uninstall those previous versions of Python 3.11. That's 0 and 1, but we'll keep 3. So if I do 3.11 uninstall. Great, so what I want to do is I want to change the version of Python. So I go Pyenv, can't remember what the command is, so if I want to change the version, so I just do Pyenv, I believe it's version, I type that in. So that shows you the current version. If I do Pyenv version 3.11.3, no, that doesn't change it. So if I do Python, I'm trying to figure it all out. Maybe is it global? Global. And if I type in Python, you see that now I'm on version 3.11.3, which is different to Python 3.10.7, which was the previous kind of global version of Python. And if I exit out of this and do Pyenv versions, you see all the versions are here, and that star indicates that we're now using 3.11.3. Awesome, so the next thing I want to move on to is virtual environments. So as you get better with Python programming, you'll be employing different packages. And within a project, you'll be having multiple packages, like for example, requests. Requests is a package that's used to be able to access online information, online materials. You hit a URL and you get information from that page, which will be actually a good example to show you. But what you'll find is you'll have different versions of that package. And what happens is you've got different projects that are going on. And you don't need to be using the same package. You want to use that particular package and that version for that particular project, and that's where virtual environments comes into play. Great, so a tool I used to use was Pyenv. So Pyenv was a really good combination of pip, which is a Python package manager that allows you to install packages, as well as creating a virtual environment. But I like to be a bit more down to earth for that. So a tool that I'll use is we type in Python venv.venv, and what this does is it will create a kind of a virtual environment. So you'll see that here. If I hit enter, and if I do a list here, this is basically creating this little folder here called VEN or Venv, which is your virtual environment. You'll see that if I go into git ignore, that we have Venv ignored. And the reason behind that is we don't want this file to be committed to our source repository. You'd be wondering then, how do we determine what packages get installed in this particular project? That's where the requirements.txt file comes into play. Now I'm going to introduce another tool that I use. It's called pip tools. Pip tools combines pip compile and pip sync. So that allows us to basically pip compile will create a dependency tree for our particular packages that we want to install, and pip sync will help us sync up those packages together. So if I go back to the code here, exit out of this, what I can do is I can activate the virtual environment by doing source venv bin activate, and this depends on what sort of shell you're using. So I'm using fish, I've got to use .fish, but if you're using bash, for example, it can be just sh. So do that there. So this activates the virtual environment, and what I could do is I could do a pip install whatever to install any packages here, but let's use requirements.env. So if I create a requirements.env, and this is what pip compile will use to create our dependency tree. So if I do pip requirements env, and let's include a package called requests. And what I'll do is I'll do a pip compile. You'll see I've got some pre-generated text here already. So we'll do a pip compile requirements.env. All this will do, will print off the dependency tree. And this is what we generated into a .txt file. If we actually did save it as a .txt file, I don't think it has. Oh, it has actually. So if you've got a requirements not .env but txt, you see that this is the requirements.txt. Now what we could do is we could do a pip install -r requirements.txt, and that'll install everything in the requirements.txt. Or we could do a pip sync. Pip sync on our requirements.txt. You'll see that there now it's installed everything pertaining to the requests, including the dependencies that are dependent on requests. And what you can also do is you can actually declare a dev.requirements.txt as .in as well. So I'll just create that. And that allows you to keep your development sort of dependencies separate from your production dependencies. So requirements.env, let's create a development version of that. And let's go into this. And we'll include a project called PyTest, for example. And we do this exact same thing. So pip compile dev requirements.txt, and we're given an output. I believe this is how you would do it. txt. And this will create, now we've got requirements.in, requirement.txt, as well as a dev requirements and a dev requirements.txt. And what we can also do is we can do something like this, where we do we do an install, so go pip install, or we do a pip sync. And we can sync both the requirements.txt as well as the dev requirements.txt. So now it's going to install both the PyTest as well as our requirements.txt. Let's say, for example, we want to get rid of requests and we want to use HTTPX instead. So let's do that. So let's go into our requirements.txt. Requirements.in. Let's get rid of requests and we'll put in HTTPX, which is basically, I think, a better version than requests. So let's exit out of this and we'll do our pip sync. We'll do our pip compile. You can see now there's different packages there on here instead of what we had with requests, and we just do our installation. So we do a pip sync on requirements and dev requirements. And you'll see it uninstalls requests and installs the things that are required for HTTPX. Great, so let's write a really quick script to test out this code inside this virtual environment. Great, so just playing around with some code and just testing it. So essentially I'll just explain what's going on. I'll walk through what's going on. So we've got test code and the main code in basically the same file to make things a bit easier. Try to ignore all these warnings here. This is basically just MyPy, which is a type checker that can't identify what these projects are. So essentially what we've got here is I've imported HTTPX, which is basically a way of being able to access an endpoint. So for example, we've got this URL here, which is just my website, and I bring it across here. So I just type in shivan.xyz. You'll see it's HTTPX. This is basically my website here. So when we hit a website, you get what we call a response code, which is a 200. So if I inspect it, and I think if I do a network, reload it, you'll see there's a bunch of 200s here. So that's kind of what we expect, a 200. Obviously the Apple Touch icon doesn't exist, so you get a 404, but make it a bit bigger. You see that if I hit it, you get a status code of 200. You just have to believe me, there's a 200 there. I can't show you it because it's too big, okay? Now let's say we enter an endpoint that doesn't exist. So if I type in does not exist, we get, this is actually a 404, not found. So let's express that in some code. So if I go back to the code here, so see here, basically you've got a main function, and what this main function does, it will basically go to that URL and it'll ask for a response code. I've commented it out now because I kind of want to show you what the test code does. Usually what we do is a red-green refractor, so you basically write your test code first, get the reds and then make them green. It'll make sense when I start writing the code, but essentially here we've got our response, and we're just going to return what the response code will be. And we expect this to be a 200. In the case where I put in this thing called does not exist, which actually does not exist, it gave us a 404 or a not found error, we'll expect this to return a 404 here. When I run the test code, and you probably saw it just before, so I'm in my virtual environment, it's all been activated. I run pytest main.py, and remember if we go into the dev requirements here, pytest was installed. And if we go into, I believe, I think if we actually go into the virtual environment, you'll see that it should be installed there. I just can't remember where it is. Or was it in lib maybe, I think. So this will contain a lot of different packages, but we've got PyTest here, and we've also got HTTPX and NEIO. All these packages are installed because of the installation of HTTPX. That's a bit of an aside. So we'll get out of this. And let's get into testing it. So we did PyTest main.py, You can see it's clicked those two tests, and they both come up as fails because they're not getting, basically none doesn't equal 200. Because essentially what happens with these functions here is because we pass them, they return nothing. So let's delete those. And let's there. So now we're going to be returning the response code. And what we expect is, if I make this 200, you're going to see that I expect this to pass, and this test main fail should fail. So let's run this. See that first one passed, and this one here has failed. Let's change to the correct status code, which is 404. And we've got 2 green passing, so we've gone from red to green, which is how we should write our code. So let's exit out of this. And what I'm going to do is I'm going to deactivate the virtual environment that we're in. And I believe I shouldn't really have HTTPX installed on this machine. So if I do a pip freeze, there's nothing that comes up. So usually what pip freeze does, pip freeze will actually freeze the packages that are already installed. I'll just run that code. So if we do Python, or if we do PyTest, it will say it doesn't exist. So let's do pytest.main.py. And obviously you can't find where PyTest is because it hasn't been installed on my computer, or not on my main system Python. It hasn't been installed on there, and that's why it can't be found. So let's try and actually run the function as well. So if I do python -i main.py, it should come up with an error saying that HTTP doesn't exist. So see, import HTTP doesn't exist because that HTTP package is inside the virtual environment. So in order for us to access it, we've got to activate the virtual environment here. And we do import, python main.py, -i. I just means it's interactive, main.py, and then we can run main here, and that returns our 200 response code. We do main fail, and this returns our 404 because that web page doesn't exist. So let's exit out of that. Great, so I'm hoping this video helped you out as you become a more experienced Python developer. Virtual environments does trip people up, especially because Python is supposed to be a beginner-friendly language, but this part actually involves a lot of skill in the beginning. So you might find that when you're using Python, you've installed all these packages onto your system, and then you realize I need to set up a virtual environment to work on a particular project, which is completely normal. So don't worry about kind of polluting your system with all these Python packages. It happened to me as well, and I got a new computer and I was able to set things up from scratch. So this really gets users, and I know a lot of people complain about Python because of version, package management, etc., but I'm hoping this is kind of a simple way of dealing with Python projects. There are things I like to do. I like to use Docker, for example. Docker helps me with pinning a particular Python version, keeping it up to date without having to install it onto my machine, which is something I really enjoy. And all the commands actually get automatically run with Docker, especially when I bring the Docker container down and bring it up again. That's something I can cover in a future video, but I kind of want to keep this brief and simple. It's probably gone on long enough. And like I said, the code will always be on GitHub. And yeah, I just really want to make these videos. Thanks for getting this far into the video. I would love some advice and feedback on this. I really want to make content to help other people out there with programming. And yeah, it's something that changed my life for the better. So I'm hoping this kind of video inspires you to help others, inspires you to make your project, because you're an inspiring developer, I'm sure. And the key to getting better at projects is to just do more projects, learn lots, and share that content around. And I think programming is a great thing, can help the world in a better way. So yeah, let me know what you think. Appreciate any comments, feedbacks, get in touch. If you have any questions, please let me know. I'm still learning. I'm on that journey with you guys, and I think I kind of want to, whatever I learn, share that with anyone, who's interested. So yeah, peace, thanks, and take care. And as always, stay focused and talk soon.